This video is an overview of the software I've created, and it's a demonstration of a program that analyzes melting curves for temperature-dependent fluorescence experiments. Key points of this program are that it can analyze multiple curves from either a 96 well or 384 well plate. The program uses solver for nonlinear curve fitting, and the advantage is that you can import all your data and analyze all your data at once, set your order, and in the end just print a report. There are off-the-shelf commercial software that can do nonlinear fitting as well. However, most or almost all of those software require you to either copy and paste data from each individual well, and that's time consuming. So this is a better solution. So let me demonstrate, get started, and then later on I can talk about the curves and stuff like that. So the first thing I do is import the data, and then what happens, it imports the file information. It sets your temperature range. You tell it which range you want to analyze. So in this case, I'm going to do 25 to 70. You import your protein concentration and your molecular weight. That information was pre-entered, and then you can have the name and the buffer conditions. The set order is pre-entered as well to save time, and you just sequentially number the order you want the compounds or protein to be analyzed. You can skip over some items as well. This is the raw data that comes in once you import it, and over here is the curve information. So let me demonstrate, and then I can talk about fitting. So as you can see, the blue line is the data, and then your red line is what's being fitted, your fit line, and then you have your R-square over here, which is being maximized. Once the program is complete, it'll let you know. You'll make a sound so that you come over and click OK, and it generates your report for you with your file information, your buffer conditions, your compound information, and your binding. So let's go back and talk about one of these curves. As you can see, I'm going to change some data here. The blue line is your data. Your red line is what's being fit. That's your, and this is the model that's being fit. And what's happening is the y-intercept for the natured protein and the denatured protein is floated. So is the slope for each, and then you have your delta H, which is the difference in the enthalpy between the two states of the protein, and then you have your melting point here. And once I click, this is your R squared, which is being, once I click update, it fits that, and you can see that goes close to 1. It's 0.9984. This software has been validated against other off-the-shelf software as well. The other advantage you have is that you can also change the range. So if you weren't satisfied for that fit, with that fit, you can change your range here, and it'll update that fit for that range. So I'm going to go back to the original so that the compound is consistent with all of us. So once the program runs and analyzes all your data, if you need to tweak, you can come back and check each compound. Finally, this is the report that's generated. as I mentioned earlier. You have your protein, and then you have staurosporin, which is a tight binder that shows your data there. And then you have your compound 2 at two different concentrations, and the KD is comparable. Compound 3, the KD is comparable for the two different concentrations, and compound 4, the KD is comparable, and the same for compound 5, and then compound 16 is not binding, and that shows that. And you just print this out and stick it in your notebook. So the advantages of this is that you can set the order here, analyze only the compounds you want to, walk away, come back, and then pick your protein.